All right, let me set the context for the video. This is a 3-hour video in which we're building an AI-based interview platform from scratch. There are companies like Mercor or other, data labs that exist that have platforms like these that help them recruit talent. There are a bunch of companies in this 𝗟𝗶 that have something similar. An AI interviewer is probably going to be the initial level of metric in some form or fashion. It actually interviews you really well. We'll understand the various approaches of building something like this, the various architectures that currently exist and the trade-offs between them. We'll also understand to create a persona for a user when they upload their resume or give us their GitHub profile. How do we scrape their information from the internet, and how you can use a proxy provider like Data Impulse to scrape data on the internet reliably. They're also the sponsor of this video, and I'd urge you to check out Data Impulse, especially if you're looking for a proxy for your scraping needs. The tech stack that we're using is going to be Bun.js for the backend, React for the front end, OpenAI Realtime for the voice AI layer, and we'll also understand other approaches and other models that exist. We'll understand speech to text, text to speech pipelines. We'll hit a bunch of roadblockers, change the architecture in the middle, go through a lot of OpenAI docs to figure this out. Voice agents are a new thing, and hence no one has yet perfected the needs of an end developer. So we'll navigate our way around that to build the final product. By the end, the product looks surprisingly good, and it interviews even surprisingly better. I've also done an interview at the end based on my profile, based on my GitHub, and you can check out the result towards the end of this video. Without any further ado, let's get right into it. All right, building an end-to-end interviewing platform. If you've seen websites like Mercor, if you've ever given an AI interview, what is the tech that goes behind building something like this? In fact, today there are a bunch of startups that are doing, AI avatars that join your Google Meets for you and answer as yourself. The tech behind it is very similar. If you want to build a voice AI, agent 𝗟𝗶H, the video will go through, the tech that goes behind building something like this and the various approaches that exist today, which one's more expensive, which one's cheaper, how can you self-host, which external services can you use, so on and so forth. Without any further ado, let's get right into it. Eventually, what we're building today is a live interviewing platform. Let's start off with high-level requirements over there. Basically, needs to be a sign-in page, and once you eventually get in, there should be a page that lets you join an interview slash interview for a specific role. I guess even before a join interview button, there should be probably a bunch of roles that are currently available to hire. For example, if you go to Mercor, there is an AI specialist role. And then there are more slightly non-tech roles available as well. Things like, a lawyer specialist or law specialist, and then environmental specialist, and, biotech specialist, so on and so forth. For those of you who don't know, the way Mercor makes money is they tend to hire these people, and then most of these people are, in some form or fashion creating data that is labeled data or training data for big labs. And then Mercor eventually sells that data up to the labs and makes, money in the middle. So they'll pay the AI specialist, whatever, $80 an hour, maybe the law specialist a little bit more, ENV specialist a little bit less. And then when they have enough data, they'll sell that in bulk to, a bigger lab and make the money in the middle. This involves, at least, they've touted to create a decently good interviewing pipeline. Generally, interviewing at scale is hard. This is probably true for, a bunch of companies like Harkirat that are probably going to go in this direction of some sort of an AI interview. If you click on this, specific link, you are redirected to another page where you're asked to, drop in your resume, and more details about yourself, your GitHub, LinkedIn, in case of your lawyer, your degrees, so on and so forth, and then finally join an interview. Once you click on the join interview button, a bunch of things happen. This is where the interesting things start. You reach a page where a lot of times there is an AI avatar on the right, and you're supposed to talk to them. They will ask you a bunch of questions based on your background, the role, how good you are in this specific niche, and then you're supposed to answer it. The final thing is recorded, and eventually the recording is available. You are graded by the AI, and then recruiters can look at your platform, your video, and decide whether or not to hire you. Mercor initially was a hiring platform. Now probably that's a very small part of their business, but this is the part that we're going to focus on. Google Meet like UI, where there is an AI interviewer on the right, which could be video, could be just audio with an avatar, could be a 3D avatar that moves with audio. And it's going to ask you a bunch of questions based on your resume, your experience, your background, and you're supposed to answer it. And by the end, your recording will be available to recruiters. they can, whatever, look at your interview and decide whether or not to hire you, or in this case, Mercor can, decide whether or not to hire you for a specific role. So probably there should be a recruiter dashboard as well. Okay, if someone does want to hire, this is the, call it talent website that looks something like this. There needs to be a recruiter website as well, where recruiters are going to come and, look at all of your recordings and see all the talent that is currently available to hire from. So they'll see, whatever. Harkirat's interview in a specific niche, could be bio, tech, and they can decide on other niches. Raman's interview, if they click on the interview, they can see the recording, they can decide to hire them. I think in Mercor, you can hire them directly from Mercor. Mercor takes a kicker. They handle compliance and salaries. We're not going to do any of that. Our primary focus is going to be this, and then, a place where you can, admins can, or recruiters can see the final video recordings. The challenges in this are mildly immense because there are a few moving parts. I'll talk through all of them. The first part is, the first mild challenge is when someone uploads their resume. I'll write them down on the side here. If this is the architecture, the harder bits look something like this. One, which is like not as hard, mildly hard, parsing the user's experience from, a PDF file. If they have their GitHub, then scraping their GitHub. If they have their LinkedIn, then scraping their LinkedIn. Whatever links they have, scraping all that data and keeping that ready for the LLM. Number two, post-start interview process. When you do start the interview, things get tricky. Here, number one, you basically need, the most standard jargon you might have heard of. The LLM is going to start with asking a bunch of questions. You need text to speech because, the LLM, based on your background and whatever we've scraped, is going to ask you the first question. You're going to hear that in some sort of a speech here inside the browser, which basically means, we definitely need some variation of WebRTC, or not variation, WebRTC running inside the browser. Then as you listen to the question, you're going to answer it again, which means you will have speech, but it'll eventually be needed to convert it to text, which will be forwarded to mostly a small language model, not a very big language model, because, otherwise the latency will be higher. These are the 4 hard bits in building any voice agent minus the video. If you actually want to, make this AI avatar actually move and, feel like a human, then probably I would add another thing over here, which would be real-time video generation, which there are lesser ways to self-host this, if any. I can think of a few approaches to make something like this, but video models, open source ones, are not as good compared to text models. Speech to text, text to speech, you can self-host and still get decently good output. The same is not true for real-time video. Also, real-time video, if you do use external providers like 𝗟𝗀, Cartesia, is very expensive. It's probably, this is a random guess, but probably 5 times more expensive than this whole pipeline. So if for an interview, it takes $0.1 for just a voice interview, it'll probably take 10 times more, like $1 for generating the video. And I don't think the output of the video is as valuable. I don't think if I'm giving an interview and I see a person actually moving their face, I'm any more scared to give the interview. I think as long as you're receiving voice, you're fine. I mean, honestly, I feel as long as you're getting some text also, you're fine. As long as the questions are what matter. If they come in an audio format, fine. If they come in a textual format, fine. If they come in a video, probably better, but probably not worth spending, 10x, 20x more in terms of your costs. And hence, we're probably going to skip the real-time video generation part. It's not too difficult because anyways, you're going to depend on an external provider like 𝗟𝗀, and we can discuss it towards the end. If you're going, it'll be harder to write it yourself or, self-host it. All of these, we can self-host. We'll see if we do that today or not. But there are like few approaches of doing speech to text, text to speech, WebRTC, and running an AI or an LLM. We'll talk about this next. What are the approaches for creating a simple voice agent? Like if I want to call, 𝗟𝗶H Nation today, if I do call 𝗟𝗶H Nation today, there's an AI on the other side and, it helps me with my bookings. The challenges there are exactly the same. What are the approaches that can be followed for any general voice agent? That could be, an AI interviewing platform, a concierge, a customer support, person on the other side, a sales rep, so on and so forth.
How would you do this today? What are the pros and cons of the various approaches, and which one's expensive, which one's cheaper? Let's get into that next. Let's understand the various approaches of doing or creating a voice agent. All right, let's discuss what is the standard architecture of a voice agent in case you want to build any sort of a voice agent, be it, a concierge that's picking up a real phone as well, or, a voice agent on your website, an interviewer like we're building today. There are a few approaches that you can follow. The first approach is also known as the cascaded pipeline approach, which is the one that you would probably arrive at from first principles. If you don't understand what voice models are yet, but you know what an LLM is, if you've done a little bit of speech to text, text to speech in the past, this is the first principles architecture that you can think of, that a browser or a phone for that matter would connect to a WebRTC server for a browser or a SIP server for a real phone call, where the browser will be forwarding the audio packets to the server. The format of these packets depends on whatever audio encoding algorithm that your browser supports. Most browsers today use Opus. Do not confuse this with the Claude model Opus. Even a audio encoding algorithm from way before 2020 or around that time I think it was released. Is also known as Opus, which is just the algorithm that you use to encode the audio. You don't necessarily, send the full audio or video in a WebRTC server. You encode it using a specific algorithm, and that's what you forward to a WebRTC server. Once you have that audio over here, you basically need to do three things, right? You need to convert the user's audio into text. For example, if the user said, "Hi, my name is Harkirat," you need to convert this into text and forward that to an LLM. The LLM is going to respond back with whatever. Hi, I am the concierge service at XYZ restaurant. How can I help you? And then you need to convert that text back to speech and send it to the browser. That's the high level of how you might think of building something like this. And there are many speech to text algorithms. This should be STT, not SST. That's what we used to learn in school. There are many speech to text models that you can self-host. There are many speech to text services that you can use, which are usually very cheap. Speech to text is cheaper compared to text to speech. Generating audio is of course more expensive compared to generating text, and hence this part is usually not very expensive and fairly commoditized. Go from 𝗟𝗶H to an open source model to assembly AI. You will not see a lot of downsides, but the benefits that come out of platforms like or services like 𝗟𝗶H and assembly AI is VAD and turn detection. These are two things that we should probably discuss a little bit. VAD, what is the full form? I keep forgetting. VAD full form, voice activity detector, I think. Voice activity detection. You can sort of work without this also, but what this does is, in case from the browser you said something like, "Hi, my name is Harkirat," it sort of cuts out the ums. Or if there's some fan noise in the background, or if you're coughing, the purpose of a voice activity detection is not just to detect if there is some audio, but if it is to detect if it's relevant audio, if it is actual speech, compared to coughing, compared to a fan noise, compared to a dog barking. And hence it just cuts down the net input that you're sending to the speech to text model. The speech to text model only receives the relevant speech and does not receive the dog, barking in the background. If, for a span of 2 seconds, you're thinking that the dog was barking, you don't necessarily have to forward that to the speech to text model. Turn detection is also something, again, you can do in-house. Same is true for VAD. There are open source models for this, but if you use something like 𝗟𝗶H or assembly AI, they sort of do it in-house for you. And hence, it makes some sense to depend on these services, considering they're not too expensive in this whole pipeline. The most expensive part over here is going to be speech to text, which again, I think I'm missing something here. And this is going to be TTS. The most expensive part over here is going to be text to speech, actually converting the final LLM text into speech. Here, even if you depend on external service, you're not, probably going to burn a lot of money. Once you get back, some text from here, "Hi there, my name is Harkirat," is when you need to, and when turn detection sort of kicks in and tells you, okay, this user's turn has probably ended, is when you need to start, streaming to an LLM, sending the full input to the LLM with the system prompt and streaming the response back from it. As you get the streamed response, you need to immediately forward it to a text-to-speech model, which is then, finally going to give you some sort of an audio which you forward back again via WebRTC to the browser. This is the first, architecture that you can think of from first principles that would basically let you create a voice agent. The problem, as you can see over here, is number one, there are a lot of moving parts, which is, mostly fine. When I say moving parts, I just mean you're dependent on a lot of external services. You can self-host most of these. You can self-host a small model. You can self-host, some open source speech to text and text to speech model. But generally, open source models will not be as good as a self-hosted model. Maybe for speech to text you can, but for text to speech, you will use something like 𝗟𝗏 for the most crystal clear audio, so on and so forth. And hence, the benefit of this approach is you can move from one provider to another. If today, 𝗟𝗏 releases a new model, you can use them. But in the future, Rubrik comes with a new voice model, or new text-to-speech model, you might want to move over to them. And it makes it very easy to, flip from one to another. In fact, there are, orchestration libraries like LiveKit, if you've heard of it. LiveKit was a lot of things, up until a few years ago. But recently, their prominent product in the voice market is the LiveKit agent SDK, or LiveKit agents, I don't know what they call it, which basically is a library that you can use that gives you a very clean SDK for this pipeline. If you want speech to text, LLM, text to speech, you can use LiveKit agents to make your life very simple. And by changing one line of code, you can move from 𝗟𝗏 to 𝗟𝗏, you can move from 𝗟𝗏 to Cartesia, so on and so forth. And if you do want to go down this route, you'd probably depend on them as your orchestration layer. Again, they don't host any models. They simply let you move from one model to another. They're an orchestration layer in the middle, a library that makes it very easy to, completely go through this pipeline. But what are the downsides of this pipeline? The real big downside, the only real downside is it's going to be slower compared to another approach that we're going to talk about very soon. But here, you of course are going to, step 1 and then step 2 and then step 3 sequentially. And hence, you'd see higher latency compared to something else. What that something else is, we'll see very soon. But does this sort of work? It works. Do a lot of companies use this? Yes. Can we use this today? We probably can. Is this easy to implement? With LiveKit agents, fairly easy to implement. Without them also, you just write the orchestration layer yourself. And, you can get state-of-the-art speech to text inference and text to speech, depending on what models you're using, and, what external services you're dependent on. We're not doing this today though. Let's discuss another way to do the same thing, which is voice models. Even though this looks like voice models, it isn't. This is like 3 different models. One speech to text model, one inference model or text to text model, and one text to speech model. What if the model itself was trained on voice to voice? What if during the training of the model, whatever model this is, the inputs were voice and the output was voice? In that case, if your browser sends you a bunch of audio, you can forward that as input to the voice model itself and it can output voice for you. So all these 3 steps sort of go away. There is no orchestration that is needed. The model itself is powerful enough to understand, incoming audio and outgoing audio, which is of course, if you think from first principles, faster compared to doing something like this, a cascaded sort of an approach. Everything happens at the model layer. It does not mean that the voice model is internally doing these 3 things. It's just that the model is trained itself in a way that the inputs were also audio and output is also audio. A lot of times these voice models are also multimodal, which means you can actually send, some sort of a text or an image or expect the voice model to do tool calls in the middle. So it's not just voice to voice if you look at it. It's, voice plus image plus text to voice plus text. That's what you'd expect out of a voice model. Is this more expensive? It is. Is it significantly more expensive? It isn't. It's like 30-40% more expensive for, a standard call that you might do. This is the approach that we're going to follow today. And this is the exact approach that OpenAI's real-time audio follows. It also makes the developer's life much easier rather than maintaining 3 different pipelines, even though, with LiveKit, it's not that difficult. Still, there's 3 services that you have to go to, put credits in there, create API keys, so on and so forth, compared to if you use OpenAI's real-time audio, it basically is a voice model, and hence you can do everything that we've discussed in architecture number 2, and hence the code that we have to write is much cleaner, much lesser. Is it more expensive? It is. Is it faster? Yes, it is faster. That's what we're going to do today. They also released a new model recently, OpenAI Real-Time 2, so we can also experiment with that. I have $5 of credits right now here, and I think that'll be enough for us to go through today's video. There is one other problem with using providers like these or voice models, which is it's very hard to move off from them to a different provider. There's no one click replacement. Every voice model has its own set of tools, SDKs, libraries, and architectures. We'll discuss some of these today. But long story short, if you do depend on OpenAI's real-time audio, it will be harder for you to move off of it in the future without some engineering effort. Cool. Let's discuss. Even inside this, there are a few architectures of building what we want to build. What we want to build is an interview platform. That means number one, users are going to come interview. Number two, after the interview is done, we also have to give them, some sort of a score rating, dump their video somewhere. There are like 5 different things we have to do compared to a simple conversation. So let's understand what that is, and let's understand the various architectures, at least on the voice AI side of what we're building today. Let's get into that next. The architecture of what we are building. All right, given our problem statement, which is a website where users come and give an interview, what we want, especially if you're depending on OpenAI, is an architecture that looks something like this. At least from first principles, this is where we arrive once we go through their docs. What we want is the browser to directly connect to OpenAI, but of course, we can't really put our OpenAI API keys inside the browser, and hence there is one extra step of the browser talking to our backend, which actually stores our OpenAI key, and the backend returning an ephemeral token, a token that is only valid once. We probably can gate how long the call is going to be based on this token. I've not really gone through the docs, but I would assume you can add a bunch of checks on this token so that it's not exploited. Once it reaches the browser, the end user can talk to an OpenAI server directly via WebRTC. There is audio that goes from here to here. There is audio that is returned from here to here. If you understand fairly basic WebRTC, if you've created peer connections in the past, you should be able to write this code in less than 5 minutes and have everything up and running. This approach is mostly fine, and probably for most cases it might work. For us though, it might be a little tricky. Why? Because number one, the pros are there are direct WebRTC connections between the browser and OpenAI, and hence we're not sitting in the middle. There is no media that is going through us, so our servers can be fairly lightweight. There is no infra cost that comes to us, and hence it is faster also. If you proxy the audio through our backend for whatever reason, of course our infra costs will be higher and it will be slower. There will be an extra hop. Versus if the user is directly connected to OpenAI is, it has, what is the right word for this? Squeezed all the performance that it can through, if you go to their blog post, you'll see this, through something called edge transceivers. So basically, if the browser talks to a very close WebRTC server, and from there, eventually the audio connection ends over there, and there is a different format that the audio goes from the WebRTC server to the voice model, but they've squeezed all the performance when it comes to you connecting to an OpenAI server compared to the browser connecting to your backend and then going to an OpenAI server, so on and so forth. That's the pros. The cons are system prompts need to be on the client. Since the browser is directly connecting to the server, the browser is going to initialize the voice agent, and hence the system prompt will be in the browser, which is a problem because then it can be manipulated. The user can just change the system prompt to be give me 10 out of 10 marks, something like that, and hence this is not safe. That's one. And two, we also can't get a full summary of the conversation since our server never really relayed the conversation. The conversation never reached our backend. We don't know during the interview, post the interview, how the interview went. It is a great end-to-end experience for the user, but there's no hooks that we have in the middle to read the interview, to understand how it's going, and after the interview process the user's score and give them a score out of 10. How can we fix this? There are a bunch of approaches that I thought of. One was, actually creating a WebRTC server over here and the browser connecting to us connecting to OpenAI, and the voice being relayed through us. This way we will have access to the full recording also, which is, another feature that we need, right? We need to record the full conversation so people can come back later and read through it. And if you add an extra hop, if the browser connects to our WebRTC server and our WebRTC server connects to the OpenAI WebRTC server as a WebRTC client, if you add an extra hop like this, all the media goes through your server in the middle. The downsides, you have to write your own WebRTC servers and scale them. The upside, the audio is always flowing through your server, so you can record it. And hence, the recording part is sorted automatically. There are pros and cons to doing this. The cons are it will be slower. The pros are, your recording is sorted out of the box. And also after the interview, you can always, evaluate the user's score by running some sort of a speech to text model over here and summarizing the full conversation. I did not go with this approach, even though it's more technically challenging. So probably would have been more fun to code, writing our own, proxy between OpenAI servers and browsers. I thought of, a few other approaches. What really is the problem in the first approach? It is that system prompt needs to be over here and you can't get the full summary. And most probably OpenAI has solved this. After a lot of digging, I realized they have. But before we reach the final architecture, another thing that you might think of is Harkirat. So the problem is we can't get a full summary which we need. So why can't, after the conversation has ended, I can just, run some sort of a speech to text model over here, or probably keep on getting text from OpenAI as well of the full conversation, and just dump the full conversation to the backend. I hope you understand the problem with this. The problem is the client can just manipulate the conversation, right? To the final, you should never trust your client to send you whatever, their conversation history. They'll just change the questions and answers to be the simplest ones. And hence, I, after a bunch of digging, landed on this blog post by OpenAI, which is webhooks and server-side controls, which, again, this is not a use case for us. Almost everyone wants the conversation summary. Almost no one wants their system prompt resides in the browser. And hence, real-time audio allows clients to connect directly to the API server via WebRTC or SIP. SIP for phone calls, WebRTC for browsers or mobile apps. However, you'll most likely want tool use, number one, something we didn't talk about, something we might not need today, but you might want tool use. And in these cases also, tools should exist on your server and not the browser. And other business logic to reside on your application server to keep this logic private and client agnostic. We do want our system prompt to be on the server and not the client. Keep tool use, business logic, and other details secure on the server side by connecting over a sideband. So they've already fixed this problem by introducing something called sidebands, which is basically another WebSocket connection in this case. For both SIP and WebRTC connections, a WebSocket connection that exists parallelly from your backend to the OpenAI server. So the user is talking to the OpenAI WebRTC server. And as things are happening over here, as the conversation is progressing, as, the user says 5 things, the model responds with 10 things. All of this you can listen to from the backend. Once the user connects, your backend can push the user's context and the system prompt to the OpenAI server through a WebSocket connection rather than it coming from the browser. So the browser's responsibility is simple, simply connect to the OpenAI server. And everything else, the summary of the conversation, the system prompt, the tools, in case we have any, we might not today, but even if you do have any tools, will exist over here on the backend, and your OpenAI server will talk to your backend directly. That way, the user has no way to manipulate anything in the middle. And you also have, the full conversation history by the end, on the basis of which you can evaluate whatever you want. The pros, the backend can listen to all the events of the conversation. So, if they feel like the user is trying to manipulate the interview, or the user is just cheating, then you can just end the interview early. The system prompt can be sent to the backend, from the backend to OpenAI through this sideband WebSocket connection. Backend se OpenAI server pe seedha data chala jayega. You don't have to, send it from the front end. So this seems like the right architecture. I'm assuming almost everyone uses sidebands. Any voice agent that you're creating with OpenAI real time, you probably want to, use something like this. You probably want some control on your backend. And this is also a slightly more complicated, even though not too complicated of a prompt statement to solve. Even though it introduces a bunch of infra challenges, like since this is, a persistent WebSocket connection, and, the browser has this voice call going on, while the call is going on for, let's say, 10 minutes, you can't really stop this server. So your servers can't be super ephemeral. You can't use Kubernetes for your servers, because if you do, it shuts down, restarts your servers or pods, very actively. Not very actively, but from time to time. You need some sort of a draining logic before your servers, die. And hence it makes the backend slightly stateful. But nothing, that is a solvable problem, and, an old problem from before. This seems like the only architecture we can use right now to build what we want to build, and hence this is what we're going to follow. I think now we can get right into the code. I don't think anything else is left to be discussed. I have not used the real-time API at all. I might just be missing something, and we might have to change the architecture. But for now, I think this is what we'll follow. Let's start start off by building the first layer, which is, a front end where user comes, uploads their resume, and we parse the resume and put that context into, some sort of a database. The first part, which is also like slightly difficult, of building something like this, and then we'll get into the voice layer and start to code this. Let's get into that next. Let's initialize our project. All right, one last thing actually before we get into the code. I totally forgot about one important component of building what we're building today, which is that we need to actually scrape the user's GitHub and LinkedIn. Eventually, our website is going to look something like this, where a user is going to come, paste their LinkedIn, paste their GitHub, click on start interview. And before we actually start the interview, before we get into the voice agent, what we need to do is scrape everything we can from their LinkedIn about their experience and their GitHub about their projects, so that the AI has context on what questions to ask. If you look at Mercor, they do take your resume as an input and ask you questions based on your past experiences. The same thing is something we have to do, and hence, this might seem like a fairly simple problem to solve, but LinkedIn makes it a little bit harder. Every website has their own policies around scraping, and LinkedIn does not, promote scraping as much. So does Twitter. Like, Twitter is also not the best platform if you want to scrape it. They do provide APIs that are extremely expensive, and hence scraping becomes a challenge for LinkedIn. For GitHub, it is not. So if the user comes and gives us their GitHub and LinkedIn URL, the first thing we do when they click on start interview is hit GitHub on api.github.com and scrape everything we can about the user, including their repositories, the star information, the number of collaborators, so on and so forth. So we have some context around what they've built. LinkedIn though, there is no API that you can reverse engineer and hit. The only way to scrape LinkedIn is to actually open LinkedIn inside a browser and then try to scrape as much as you can about the user's experience. This is why there are a lot of businesses built around, LinkedIn and Twitter scrapers, because they're just harder to build in-house. But today we're going to use Data Impulse, which is also the sponsor of today's video, to proxy our request to LinkedIn. This is like a standard use case you'd find for proxies, which is if there is a website that is hard to scrape, which is LinkedIn, which is going to, rate limit you, do a bunch of bot detection. There are like 10 different strategies you have to use to ensure you're able to scrape data from a website. One such strategy is proxying your request from different servers around the world rather than sending a direct request from your backend. If you do send a direct request from your backend, at some point very early you're going to get rate limited. But what we'll do is, rather than opening the browser on linkedin.com/𝗟𝗶H from our backend so that the IP that LinkedIn sees is ours, rather than doing that, we're going to send that request through a proxy. So every time LinkedIn sees a different URL, a different IP, of where the request is coming from, and hence we don't get rate limited. There are a bunch of other use cases of, proxy servers, but this is the one that you'll use if you want to scrape websites, which today is like one big use case for a lot of companies. In fact, a company that hires through us, Valence, hired 2 data engineers whose job was exactly this, which was making sure how best can you scrape websites, including, avoiding rate limits, bot protection, things like these, CAPTCHAs, and making sure you can actually read the data. I was just going through Data Impulse docs and I realized they do have docs around how can you make Data Impulse work with Playwright. So that's exactly what we're going to do. What we're going to do is, once the user comes and clicks on start interview, hit GitHub on api.github.com and use the code that we saw over here to open a browser using Playwright, but proxy our request through Data Impulse so that we don't get rate limited. That is also, one big thing we have to do before we actually get into the voice layer. Given this context, let's get into the code base. Let's start by coding maybe a very basic front end, an endpoint, a basic endpoint that is going to take these 2 inputs and gather all the data from GitHub and LinkedIn. And then we'll see how can we summarize that data and have everything ready in the context before we actually get into the voice AI layer. Let's get into that next. Let's build this part of the code base. All right, let's kick things off by initializing a fresh turbo repo. Most of our code is going to be in TypeScript, if not all of it, probably all of it. So let me create a new project called interview Mercor. Let me initialize a new turbo repo by running bunx create turbo @latest. I use bun these days. I don't know what you guys are using, but would urge everyone to probably move over to bun sooner than later. Let me also open this in Cursor. There you go. I have cursor, which has this project running. And while it install the dependencies, let's quickly look at the apps that we have. We have two front ends. Let me get rid of one of them, which is the docs front end. Let's have one front end, and eventually we're going to need a backend. I think that's good enough, right? This is like not as big a project to follow through on. So I think backend web. Let me quickly go to apps/backend and do a bun init over here. And I think by default the front end would be Next.js. I'm just going to stick to, you know what, either is fine. Next is fine. React is fine, but I'm just going to keep things simple with React. So I'm going to create another folder called front end, do a bun init over here and select React as the library, and 𝗟𝗶 plus Tailwind as, you know, the two frameworks that we're going to need for styling. And that's pretty much it. Now we have app/backend where we're going to write our backend code, app/frontend where we're going to write our frontend code. Our frontend for now is going to be pretty simple, right? Let me get rid of all the code that exists over here. And we're going to have, as you remember, two input boxes and a button. So man, has it been a lot of time since I've written front end, but let me try to write some Tailwind again. We basically need them in the center of the screen. So, you know, since we do have Tailwind, I want this to be H screen, W screen. That means take the full width and height. Flex, justify, center, align. This one I don't remember for vertical alignment. Align center, I think. Let's see. Hi there. Or let me just add two input boxes. One input box, another input box, followed by a button, which has, you know, start interview, something of that sorts over here. Let's see if this looks good or bad. Let me do a bun dev inside the front end. Let me go to localhost :3000, and boy, I see 0 styles. I think I have to import index.css. It's some CSS. Let's see. Style/global.css. So import styles/global.css, and now refresh. There we go. It looks prettier, but it's still not horizontally aligned because align center is probably incorrect. So align items center Tailwind. Items-center is the class that we needed and not aligns-center. And now hopefully it is vertically and horizontally aligned. Still are a few things to fix. I would give this a placeholder of LinkedIn URL and this a placeholder of whatever, GitHub URL. And then this needs to be centrally aligned. So divs class name equal to flex justify center. And this button should be centrally aligned and padding all around. So class name equal to p-4, and just copy that over to this guy and maybe this guy, p-4. All right. Div class name equal to p-4, and then some more padding on the one below. There you go. Decentish, not great. You know, need some sort of a header here that says, you know, text. Interview, AI interview, kickstart. I don't know, whatever the title is. How do you text in 𝗟𝗶? Let's see, typography. 𝗟𝗶, something like this we need. View code. I guess I'll just copy this. Seems like there's no typography component as such, but this works for me. And now, hopefully, there you go. Decentish AI interview kickstart. Paste your LinkedIn URL, paste your GitHub URL, and then once you're done with both, we're going to send a request to the backend to kickstart the interview, and then redirect the user to a different component. So, I mean, ideally, add routing over here, use React query to hit the backend. Since the frontend is very simple at the moment, I'm just keeping things a little too simple. I'm going to add two components, one called form.tsx and one called interview.tsx, and you will just flip through both of them based on whether the interview has started or not. And then eventually we probably need like a result.tsx once the thing is done. Let's start off with moving all the code that I had here over to form.tsx. So export function form, return this, and then copy these two imports, paste them here. There we go. That should do it. And then the second thing we need is this guy is simply going to render the form component. Now the front end should still look the same. Now the form is rendered initially, and when you click on the button, you move to the other thing. So let's add some state variables here. Const page comma set page equal to use state form or interview or result. You might be in one of three states, and you kick things off with the form state. And if page is equal to form is when we'd render this. Again, ideally use something like React router for routing. I'm just not, I'm just complicating things lesser and doing this. If it is interview, then render the interview component, which I'm going to add here. Oh, my bad. My bad here as well. All right. And then lastly, if the page is results, then simply render the result page, which I'm going to add here. Just going to copy interview, paste it here, and replace this with result. Go back to app.tsx, paste result here. Cool. Now, when the user clicks on the button, what needs to happen? So I think that should, man. Yes, I mean, honestly, it just makes sense to add a React router. The front end will just get ugly, which, I don't love, but yeah, let's just keep it ugly, I guess. It's fine. When you click on the button, a few things should happen. Firstly, let's add two state variables for GitHub. Set GitHub equal to use state empty, and the same is true for LinkedIn. I mean, React query and React router exists for a reason, so you should use them. Just because I'm being lazy doesn't mean you should be lazy as well. There we go. And now what I'm going to do is input on change equal to set GitHub e.target.value, and then the same is going to be true over here. This is going to be GitHub. This is going to be LinkedIn. Add a function called on submit, whose job is, whenever you click on this button, it gets called, and its job is to hit the backend. Again, if you really think about it, add TRPC in here, use 𝗟𝗏𝗀, add end-to-end type safety, which we're not right now. There's a lot of full stacky things that you can do here that are better than what I'm doing. I'm just building the most, native, naive version without thinking too much about it. If not GitHub or not LinkedIn, then, simply, I'm sure there's like toasts in 𝗟𝗏𝗀. Let's see. Oh, sorry, wrong one. This one, toast. Oh, there we go. There are toasts. Having deprecated the song component is instead used. Alrighty. Bun add sonar, and then when you click on it, toast with whatever. So in our case, we're going to toast the user with please provide valid, whatever. Please provide valid GitHub and LinkedIn URLs. Ideally, you want to do add more validation here to ensure they're valid, whatever GitHub URLs. Probably don't need it. Simple toast is good. Now if I go to the website and OneDev, if I go to the website and click on start interview without putting anything here, I don't see a toast. And the reason for that is I need to add the toaster here somewhere. I can add it at the end, which is what actually renders the toast. And now if I go here and click on start interview, I see a toast at the, oh, you guys don't see it, do you? Let me just change its location to bottom left. Location, or top right, just like we saw on 𝗟𝗏𝗀. See, code. How do you add the location? Sonar location of toast change. Position bottom dash left. That way, now when you go here, refresh, click on it, you see it on the bottom left. Beautiful. If you add something valid is when we need to actually start and hit the backend. So here I'm going to do a bun add Axios and do an Axios.post. Let me add a config.ts file here, export const backend URL equal to localhost :3000 backend URL /API/v1/ pre-interview can be a good endpoint that gets hit pre the interview, which is going to accept the user's LinkedIn URL and GitHub URL, and then there can be another one that actually joins the interview right after. All right, so let's do this. That's good. That's all we need up until now on the front end. User comes, puts their respective links. If I right click inspect, go to the network tab and click on start interview, I would have hoped for a bun dev, refresh, put a LinkedIn URL, a GitHub URL. When you click on start interview, you send a request to the backend endpoint /API/v1/ pre-interview with the right payload. The front end is running on 3000. So let's just run this on 3001 and start to write the backend code now. I have some basic boilerplate for feature 1, which is, the front end is hitting the backend with the right endpoints. The backend now, it already has been initialized, is going to create an HTTP server, which, as I said, ideally use whatever. There are like a bunch of libraries now. Express is not the only one. So use Fast API, use, what's the other one? Hono, use TRPC, use 𝗟𝗏𝗀𝗀, use Effect, use whatever to create your backend. And there are reasons, or use Next.js, which has both the front end and the backend, because there's no real. Yeah, I mean, honestly, Next.js is also not the worst single folder that we could have had here. We separated the front end and the back end, but there was no real need for it. So I'm doing now the most native route of using an Express server, but you can do whatever you want. And I would probably urge you to not move beyond this a little bit. It's like, or not, I guess. The main part of this website anyways is the voice agent, so it doesn't really matter. All right, this is the endpoint. This will get hit, and then first thing we should do ideally is check that the URLs are valid or not. So app.use express.json, and then bun add zod, add another file here called types.ts, import z from zod, just add schema validation, export const pre-interview body equal to z.object, which has a LinkedIn, which is a z.string, and then GitHub, which is a z.string. LinkedIn, I think. Let's confirm from the front end. Yeah, LinkedIn, GitHub, const success, comma, data equal to, what is this called? Pre-interview body dot safe parse reg.body. If not success, that means the user sent us some incorrect inputs. We simply return with the rest.status 40411.json message incorrect body. And then if everything is good, is when we need to now start scraping GitHub and scraping LinkedIn. Scraping GitHub, easy part. I mean, one bad thing now is the user gave us the GitHub URL, const GitHub URL equal to data.github, and then const LinkedIn URL equal to data.linkedin. But that also means, okay, this looks something like this. /Harkirat. So we basically need to strip out everything. After the last slash is when the URL exists. So I guess this is good enough. Const GitHub username equal to GitHub URL dot split slash of the last element, so dot pop. That should probably give me the GitHub URL. I should add some tests here to confirm, and probably the same is true for LinkedIn. Let's see. That may not be true for LinkedIn actually. I'll tell you why. If I open my LinkedIn, thing, actually this might just work. There's an extra slash at the end. Actually, that wouldn't matter. That would matter. Pop. Thing is, if I paste this right, if I paste this, there's an extra trailing slash. So what would happen is something like this. Let LinkedIn URL equal to, if it is this, and I do LinkedIn URL dot split slash, notice the last element is an empty string. So dot pop would return me an empty string. So I should probably just strip out the last slash. How do you strip out the last slash? Dot trim slash, does that do anything? Does trim let you provide inputs? No. I'm just trying to find the elegant way to do it. I want to strip any extra slashes from the end. Data.github. Ends with slash, then I would do data.github. Actually, there's like a generic, I mean, it's like ugly solution, but generic. This is like me writing how LLMs write code. Yeah, that should do it. Dot split slash dot join slash. Yeah. This will remove the initial and the last slashes if there are any. Dot split slash would convert, this to something like HTTPS, colon, empty string. Actually, this might just make it a little more problematic, but it's fine. It will get rid of the ending slash. It might just get rid of a few slashes here as well. So it'll basically convert it to this, but it doesn't really matter for us because, we have a slash over here. Actually, Will it fix it? Now I'm skeptical. Let's see. LinkedIn URL. Nah, I didn't fix it. Okay. Yeah, you always get stuck at the weirdest issues, man. What if the user adds an extra slash at the end? Okay, let's just do the naive thing. Dot ends with slash, then it will be everything minus that. So it will be this thing. Dot splice 0, -1. I think that will split it towards the end. I think dot slice, one of these two. Else it will be data dot GitHub, and then the same thing over here. But let me just confirm really quickly. LinkedIn URL dot slice 0, -1. Yeah, that removes the extra slash, right? It got rid of it here, so that should be good enough. And then the same thing over here with data dot LinkedIn. Beautiful. There are more edge cases, which I'll add a to do here for. URL can be very malformed. Probably use an SLM here. What we can, basically the user could have sent me something like this, right? There might be, when we copy paste LinkedIn URLs, we paste them in haste. So there might be some things after it that'll pollute the thing. And hence there are ways to fix it. And the easiest one is just, forward the very long LinkedIn URL to an LLM. The LLM will tell you the actual URL of the user. Only thing is, one, you're introducing an LLM call. So maybe introduce like an SLM, a small language model that runs on your machine and figures this out. Just thinking of random approaches too. Find the URL given the LinkedIn. Now, given we have the username given the URL, we need to now figure out everything about the user. The good thing is, one, add Axios. As we discussed a while back, GitHub exposes this very easily on api.github.com. So I can simply hit, .get api.github.com /repos, I think, /username. And this should return me everything about the user. Let's confirm that. api.github.com users/@Harkirat/repos. So something like this. That should return me everything about the users repositories, which is a little too much information. User repo info like this. We can, we probably should make this a little more cleaner and not have this much context for the LLM about the user. Doesn't make any sense for folk true to go over there, or URLs to go. Probably one thing we do need is like the description and what's happening inside the repo, which is not over here. So yeah, I don't think this is like good context we're maintaining. Ideally we should, yeah, well, it gives us what you can do to get things further. What happens if I go here? Yeah, there you go. It has a description, right? So ideally for most of the repositories of the user, let's do that. We should probably, fetch their descriptions. Okay, what was he doing inside the 2048 repo? And the answer is it's a small clone of 2048. And what was he doing inside, I don't know, Agario repo. So if you go to this /agar.io, it'll give you like a small description, which in my case I was null. Are there any descriptions here? That would have been nicer, but the answer seems to be no. I can't find the description of individual repos, so I'll have to hit them, individually again and again. Let me quickly charge my laptop. Sorry about that. Since I started to charge my laptop, my mic died, so let me re-record this. I've not done too much since. The full name of the repo and the name of the repo and thankfully the description of the repo are actually part of our original API request, and hence we don't need to keep hitting individual repo level requests. This very big dump of all repos does contain the description, which is enough for us before we start the interview. And hence, if you look at the code, I hit this endpoint and then I just filter out this very big response into just the description of the repo name and the full name of the repo. That's probably good enough. Maybe one more thing would be star count or something, if this is like a famous, there you go, stargazer counts. I'll also add that, star count x dot this thing. That's probably good enough. We have some context of the user's repository, and then we can dive deeper during the interview based on this. Great. I've logged it for now, and now comes the next more difficult part, which is scraping LinkedIn. It involves actually starting a browser using Playwright and proxying the request via data impulse to make sure we're not getting rate limited. Also, there are challenges in parsing the final response from LinkedIn and figuring out, what the user's experiences look like. And that's going to be, a little bit of a challenge. Let's get into that next. Let's do the first difficult part of the video. I think everything else was simple until this point. The first difficult part of the video, actually scraping LinkedIn data and proxying our requests via data impulse. All right. After a lot of work, I've realized two things. One, scraping is really hard if you have to open a browser. I spent around 2 hours trying to create a half good LinkedIn scraper. LinkedIn makes it really hard for you to scrape, whatever experiences of people or whatever we might need in this case. At the same time, it is a very interesting challenge to try to scrape one of these, heavily protected websites, be it Twitter or LinkedIn. So I would urge you to try this yourself. I am probably not going to do this, at least on YouTube. You might find some code lingering somewhere. But try it as an assignment. I think you guys understand the general tech stack for this, which is primarily something like Playwright that lets you open browsers. And a standard approach might be either opening a browser, logging in through a dummy account, and then going to someone's LinkedIn, or somehow dumping their cookies somewhere so that every time you reopen a browser, the user is sort of logged in and you can keep going. Probably have like 20-30 accounts that you can rotate through, and use some sort of a proxy like the data impulse to make sure you're not getting rate limited. With that, I am going to now show you another problem and remove LinkedIn from almost everywhere. So that's the inputs. Over here, and from the front end as well. So over here, and now I'm going to spend my time on one more problem that you'll see. You might not, you probably would know this, but all these endpoints, specifically unauthenticated endpoints by most API providers, will rate limit you at some point. So if I keep refreshing, api.github.com, and eventually our backend is going to be hit by a lot of users, you will get rate limited. Rate limits for this specific endpoint are 100 per minute, I think, something like that. And hence, as our application scales, we will not be able to hit this and get the users' repositories. But a fix around this is what it is: proxying your requests through various IPs, because the way you get rate limited here is not because of some token, like some sort of an auth token. There is no auth token that I'm providing to GitHub over here. It's primarily the IP, and this IP of mine right now got rate limited. But if I proxy this request via data impulse, so if I send the same request, if I do a curl api.github.com, I will get rate limited. But if rather than doing a curl, I send a curl through a proxy, like the one I have here, I will be able to send this request. Why? Because my request will be going through not my personal IP, but a different IP. Now I got all the responses from GitHub because my IP is being rotated. In fact, if you hit my ip.com or whatever that URL is, api.api.org, you will see this website's job is to return you your IP. So if I right now hit this, it will return me my IP. But if I hit this again and again through a proxy, every time I get a different IP address, because my origin server is sort of changing every time. I get a different proxy that I'm hitting this URL with every time I sort of hit it through a proxy. This is one thing we need to add to our code base. And how do you do that? Proxies are like general concepts, right? If you've ever been to a college, a lot of times your college would want you to proxy because the college proxy will block a bunch of websites. So the concept of a proxy sort of exists generally. The way to send a request via something like Axios in this case is to pass in the proxy arguments, which in our case is going to be the URL of the proxy. Let's see what these look like. Host, port, auth, and protocol. So let's copy all 4 of these. The host for my proxy, which I will disable by the end of the video, is, wait for it, gw.dataimpulse.com. Protocol is HTTP. Auth has username, which is, this thing right here, which I'm going to probably get from an env file. So let me create a top level .env in my backend, and let me add data impulse proxy user equal to this thing, and then data impulse proxy password equal to this thing. Now I can simply write process.env.data impulse proxy user and ensure that it exists, and password, same thing. There we go. Port in our case is 823, and protocol is HTTP. Now let me try to hit our backend. So if I do a bun cd apps backend bun index.ts and go to Postman and send a request to basically this endpoint with just GitHub now, not LinkedIn. Let's see if I get back my, do we do that already? Yeah, if I get back my GitHub data, if I send this request, I get back a 407, which probably means the proxy request failed. What is a 407 status code? I'm just curious about what a 407 status code is. Probably some sort of a proxy fail. Proxy authentication client response failed. Okie dokie. Let me quickly log these to ensure that the username and password are correct. And do it one more time. Go to Postman, send a request, and now I do see the correct username and password. Still fails with a 407. Let me quickly debug. Alright, that took some fixing. Seems like this is some issue with Axios itself. This is the Stack Overflow answer that I followed, and it just suggested using a different package called HTTPS proxy agent. I'm assuming Axios has some issues about proxying requests via HTTPS. That's my guess. Whatever they suggested over here, which is adding another HTTPS agent while making the request, is what I added, and it worked. This is what the code looks like right now. I've added another package, which is the HTTP proxy agent. This takes the process.env.proxy URL as an input, and let me go to .env and add that and remove these. And now I'm able to send a request to GitHub proxied through data impulse, and hence I know I will not be rate limited irrespective of how many times I send this request. Cool. Given we have that, can we say that we're done with the first part? If I now start the front end and go to localhost 3000, if I put my GitHub URL over here, which is this, and look at the network tab, clicking on start interview fails because I get a course error. Let me quickly fix that. Let me remove the console.log, wherever that is, and let me add types /course as well. And now if I do a import course from course and run oneindex.ts, send a request via Postman, it works. Send a request via the front end. The request goes out and I do get back a 200 status code. So we're good with the first part. Now comes the second part, which would include a few things. Yeah, we basically need to take the user to the next page where they actually start the interview, and do a voice chat with OpenAI with the right context. So basically the second complicated architecture that we saw at the beginning of the video. Let's get into that next. Let's finish this. Let's start a real interview after this, which is going to be a voice interview where I can talk to the AI and the AI is going to ask me questions based on my GitHub profile and the sort of repositories I have. In the future, we can extend this to maybe some contributions that the user made. Like if you do go to github.com/𝗟𝗶H, you can actually see what all contributions they've made recently and probably the actual pull requests as well. Might make sense to add that context, but for now we're going to just work with the repos and work on the interview part next. Let's get into that next. All right, let's get right into it. We probably need a database here to persist, pre-interview, post-interview, everything. So let me quickly initialize 𝗟𝗶H. There are a few steps now, so I always go through the docs. Let's do a bun add a bunch of dependencies, followed by bunx 𝗟𝗏 init. Basically this command minus the --bun flag. My bad. There we go. And now let's create a schema for our application. Should be simple enough. There's no real authentication here. It's simply interviews, I guess. So model interview, which would have an ID, which is string is fine, I guess, which defaults to a UUID. Followed by probably the GitHub repos, where each will probably be like a foreign key, won't it? Let's just add metadata, or what do you call it? GitHub metadata, which will be JSON. It'll pretty much contain the full very big JSON blob of whatever we could scrape from GitHub. We can structure this more, but JSON is fine for now. And status, which would be probably some sort of enum. Interview status, which would be either pre or done, or pre as in so it's just started. The interview hasn't yet started. In progress or done. And then finally a score out of 10. So that would probably be a integer, and that's it. An interview will have 4 things. I think this should be fine. At some point we should add authentication, make sure the user, the conversation is probably something we need. So a model conversation, basically the full conversation that the user had with the agent, should probably be stored somewhere. ID defaults to UUID, followed by the message, which would be string, followed by who made the message. So type, I guess, model conversation type will either be user or assistant. My bad, it'll be an enum. And there'll be like a one-to-many relationship between an interview and conversations. So every interview can have a bunch of conversations or messages, what was probably like a better name for it, I guess. And then every message is going to belong to an interview ID, which will be string, interview at relation fields. Interview ID belongs to or references the ID of the interview table. I think that should cover our schema. Every interview is going to have a bunch of messages. between the AI and the user. So them converted to textual format is what we're storing in the database. Why? Because eventually we'll have to score based on this. Score should probably be, I don't know if option is the right. Let's just default it to 0 and eventually we'll update it when the status changes. Other than that, I think this is fine. The GitHub metadata, which we'll forward to the LLM. Yeah, this is good. Now, once the user is done with the interview, we should probably make an entry in the database. So I'll do a... Oh, we probably need a database now, don't we? Docker PS. Let me start Docker locally. Let me run Postgres using Docker. So Docker and Postgres... with a password. So that's Postgres underscore password equal to Postgres. And let me run it in the background. That starts Postgres in the background. In .env, let me replace this very long URL with Postgres at localhost :5432. Our username password are both Postgres, and the DB is probably going to be called, let's call it Mercor. That's good enough. Cool. Let's do a Bunnex Prisma migrate dev. And it says there's an error, can't find .env/config. So let's do a bun add .env followed by a migrate. I'm going to call it init, and now it seems like it's applied. It's a local database, so happened fairly quickly. I'll still confirm once. Docker ps docker exec sh followed by a psql -u Postgres. Use the database Mercor. I think this is how you do it, right? Select or /dt show databases, show database, exit oh man, okay, psql-u postgres-d Mercor. psql-u postgres-d Mercor. There we go. /dt. There we go. We do have an interview and a message table, which basically means our migration did work as expected. Now I need to do a Bunnex Prisma migrate. To migrate my database, go back to index.ts. So we already did this. I need to do a Bunnex Prisma generate. To generate my Prisma client, I think there is one more step now. You have to create some sort of a db.ts file, which will export Prisma. There's like a lot of boilerplate you have to add to basically get Prisma running, but this should be good enough. Now I can import Prisma from /db and then do whatever I want with my database, and which in this case is going to be Prisma dot interview dot create a new interview with the GitHub metadata as json.stringify GitHub data. And what else do you need here? Score defaults already. Status as pre. And that's it. Whatever ID we get back from here is what we'll return to the front end along with. We probably don't even need to return this. So ID would be interview dot. ID, that should be good enough. Now we actually have every interview going into the database. And when the front end hits this, what we can do is, yeah, this was already a problem, wasn't it? When you click on submit, you probably need to just change the status of the original thing. I mean, ideally add React routing here. I mean, let me just do that. This will just get very ugly if we don't add React routing. So let me quickly add that. React router. One add React router. And browser router. Man, they've made these docs so bad. I always have to go back to my memory. Import browser router routes route from React router, followed by, let's get rid of this ugly logic. Route path equal to landing page, element equal to the form component, followed by path equal to /interview/id, should render the interview component, and then the third one is going to be the result component, so /result/id should render the result component, and we're good to go. Now we've added routing to our application, which also means when you're done with the thing, you can simply navigate const navigate equal to use router or use navigate, and then let the user navigate to /interview/ response.data.id. Cool. Now if I go to localhost 3000 with the front end on and the back end on, I can simply give my GitHub URL, which is going to be this, paste it, click on start interview, and I will get hopefully redirected. I do. Took a while, but it did redirect me. Add some sort of a loader to this form, const loading, set loading false, followed by just set loading to true when you're sending the request, and put this inside some sort of a try catch, and disabled equal to loading, and if it is loading, then give some sort of a text. Starting interview or something like that. Cool. Now if I go back here, put my GitHub URL and click on start interview, it gives me some sort of a feedback and then eventually redirects me here, which is where the actual interview needs to begin, and hence we need the voice model integration over here. This section you would need OpenAI credits, especially if you're using OpenAI's real-time API, which is something we're using today, unfortunately. As I mentioned initially, there are many approaches, but almost every approach, unless you're self-hosting voice models locally on your Mac, is going to involve whatever, you having to pay someone. In my case, that someone is OpenAI. So if I go to OpenAI platform, I do feel like I have some credits in here. Let me quickly log in. Yeah, I have like $5 in here, and that should hopefully be enough for me to go through this video. Let me create a new API key called voice. Now I have a secret key that I'm going to copy and paste in my .env. Let's call it OpenAI key equal to this thing. And now I'm hoping this key is enough to use their voice agent. So the next step is just going through their real-time API, OpenAI docs, and figuring out what we have to do, which in our case is we want to create a voice agent. Let's get into that section next. Now that we're done with some basic schema database design, let's get into the part where we do the original architecture that you saw, which was we're going to connect the browser directly to OpenAI through a voice agent, and use a sideband that connects to the OpenAI server, and keep a track of the conversation. Let's get into implementing the voice agent next. All right, it's my first time implementing this as well. I have some experience with WebRTC, so this is like fairly easily readable for me. For those of you who don't, I would urge you to go through like a quick WebRTC peer-to-peer, 101. Just understand what SDPs are, how the key exchange happens, and how does one connect to another browser or a server. For real-time communication, back and forth. How do you send audio? How do you receive audio, video, data channels, so on and so forth. I'm not diving too much into how WebRTC works, but consider that to be like a fair prerequisite if you want to understand everything that's happening here. All right, kick things off with. So I've opened two docs over here. One, how do you connect to the real-time API with WebRTC? Number two. Is this sideband discussion that we've done. I hope I have the architecture somewhere here. I don't think I do. I think I lost all of my architecture diagrams. Let me quickly grab the right one. All right, this is the architecture that we saw a while back. Step one is just your browser hitting the backend, getting back an ephemeral token and connecting directly to OpenAI through WebRTC. That should be here in the first doc. So let's read through this. Creating a session via the unified interface. To create a real-time API session via the unified interface, you need to build a small server-side application, which we are. Create a session config. Expose an endpoint that hits OpenAI. I don't know what this is. Okay, that might not be the right one. In your or would it? That'd probably be the right one. Or maybe not. Let me read through this. Alright, both the approaches are fine. Both will let you do something similar. I like the first one a little bit more, and hence I'm going to go with the first one. The first one is a little complicated. It would basically involve you first creating a WebRTC connection inside the browser, creating an audio element, attaching any incoming tracks to that audio element, then fetching your audio from the mic, and attaching that as an outgoing audio. So all incoming audios are getting attached to an audio element, and this is where we're sending out the outgoing audio. I don't think we need data channels, so we can probably skip this line. Create an offer, set local description, then hit our backend endpoint, which is above over here. This one right here. This guy's job is to talk to OpenAI. I don't know. I still don't know what this is. I'm sure it exists for a good reason. We'll figure out what that is. And then this is going to return you the SDP, which you forward back to the client, which the client gets over here, and then just sets the answer on the WebRTC connection. Basically, the connection is made. Let's test it out. Let me copy this full code. Let me go to cursor, the interview page, and let's do something like this. Whenever this mounts, we will have access to like a room ID, right? So const interview ID, and probably the same thing here. Interview ID equal to use params, I think, and anytime the interview ID changes, I basically would want to create a new WebRTC connection. All right, create a new RTC peer connection. This would probably involve creating an audio element here with autoplay set to true, and let's create like a ref. So const audio ref equal to use ref HTML audio element. What's the problem here? And ref equal to audio ref. If you don't know what refs are, you probably need to read them up. Do a little bit of React learning. Audio ref dot current equal to this thing. Audio ref dot current dot autoplay equal to true. Audio ref dot current dot source object equal to something. Media stream undefined. Oh, assume this exists as well. Yeah, around here I would want basically this to be an async functions or something like this. A bunch of smaller JavaScript concepts that you have to sort of know. One that I'm introducing here is ifs or immediately invoked functions. But there's like a bunch of small things here. One, creating an RTC peer connection. So you need to know what WebRTC is and what exactly this class does. Then attaching any incoming audio to an audio element. Then calling this navigator.mediadevice.getUserMedia. Basically, if I copy this, go to a random website and paste it here, it basically asks your mic for permissions, as you can see, something like this, and gets back the audio stream from it. I'm going to allow this time. So now this website has access to my mic, and whatever this guy returns basically is has get tracks is fine. Okay, this should exist. Yeah, whatever we get back from here is what we're adding, which basically means that's our outgoing track to OpenAI. I don't think we need this, so I'm just going to comment this. Create an offer. This is the slightly more complicated thing that I was talking about, session description protocol, or the SDP, which basically is all your information about your browser, the video codecs that you're using, or in this case the audio codecs, your IP address port, things like these. This is how OpenAI's servers sort of reach you to send you audio and you sending them back audio. This is just you setting your own SDP. This is our front end talking to our backend on the /session endpoint that we need to implement on the backend. Let's call it /API/v1/session. Copy, and then let's expose that from here. And this is pretty much going to have what they exposed over here, but there's one big question mark, which is what exactly is this. Okay, one, we need this, another middleware for the SDP that comes from OpenAI, which is not JSON but text. Number two, this session config, and number three, this basically has what model we're using, what voice is the final output going to be on the other side, the bot's audio, and then this request to OpenAI to get back, to send the user's SDP and get back the OpenAI SDP. So the question is, where does the user SDP come from? rec.body, okay, which basically is this, and I think that's what we're sending here as well. That should be fine. Send the user's SDP to OpenAI, get back OpenAI's SDP, send that back to the front end over here and then set it up. I think we should be fine. Type answer SDP sponsor. I think this should just be answer.stp. I don't know. You can see a type error already. What inputs does SDP and type? All right. I guess that's fine. SDP type are incompatible. How? Answer. I don't know why there's an error here. String. Okay. Never mind. Yeah, I wouldn't worry too much about it. Don't worry about what happened here. Just TypeScript being TypeScript. Cool. Let's see if it works. I think we're pretty much done. One weird thing that will happen is we have strict mode somewhere. Let me just remove it. It just makes the effects go down twice, which we don't want. We want this effect to only run once, and probably should add a bunch of logs. So console.log, hi, and then hello. That should create a WebRTC connection between us. I don't know if there will be a conversation yet. We'll see. Let's run the backend again. Let's run the front end again, and maybe we should add some logging somewhere. I've added a hi here and a hello here. I probably should log. I mean, never mind. I think it will inspect everything. Localhost 3000. Take Harkirat's GitHub URL. Paste it over here. Open the network tab. Click on start interview. All right. Create interview request. Interview has been created. Asks me for mic permissions. I have allowed. And then this request fails with a 405 method not allowed. API v1 session post and 405 method not allowed here. Why is it sending it on 3000? My bad. The request should go to the backend endpoint. Alrighty, that's my bad. Let's restart. And now, is there like another error? Session now returns an error. Incorrect API key provided. Alright, that seems like a solvable issue. There we go. What does my .env have? OpenAI key and not OpenAI API key. Let's try that one more time. Refresh. And now session does return me an SDP. There's probably an audio element here. Hello, hello, hello.
Je t'entends. Tout est nickel. Alors, tu voulais un petit coup de main pour un STP?
Hello. Wait. What language are you speaking in? Speak in English.
Hey there. I'm speaking English, just like you.
Beautiful. Man, tone detection is crazy.
Thanks. Yeah, the tone detection can be pretty sharp. I'm glad it's working well for
Can
you.
I interrupt you and ask you to explain Rust to me?
Of course. I'd love
No,
to
wait.
explain.
I want. Oh man, that's fucking crazy. Really good. I don't know what model that is, but I don't think I've seen this good audio. Alright, never mind. Let me close. Alright, step one is done. Which is, I can talk to the AI. My cat's scared suddenly. I think fairly scary voice Marlin has over here. Next up, creating the sideband connection. So everything else is done. What is left is this. I can't believe it happened the first time. This part, slightly tricky part, we'll see very soon. I want to see how much money I've spent just talking to Marlin for like a few seconds. I had 4.8 and now I have, wait for it, 4.74. Yeah, it's pretty expensive. It's like less than a minute worth of a conversation. That's like really expensive. Cool. Let's get into the next part, the sideband part, and let's sort of create an interview with the AI. Alrighty, last part I would assume, the WebSocket sideband connection through which we're going to forward the system prompt and the GitHub repos of the user so that the AI has enough context to what to ask to the user, and also intercept the whole conversation so that we can actually store the whole history in the database, eventually evaluate the user, so on and so forth. So let's kick things off with probably somewhere here, like right after, I want to create a WebSocket connection. So initialize sideband with probably the ID and a bunch of other things. Oh, there's like a call ID though. The thing is, when you initialize sideband, you need a call ID. Question is, where do you get that from? Where is the sideband docs? Yeah, there we go. This is contains a location header which has a unique call ID. All right. Beautiful. There we go. So we should be able to get a call ID from this SDP request somewhere here. So I would just call this R. Stacy. And maybe replace R with SDP response. Here as well. Here as well. And now I need to call. I could have sworn I wrote init WebSocket somewhere, but never mind. Init sideband with can probably be after. With the call IDs, that's this thing right here, and maybe the interview ID. We never took that as an input, did we? Probably need to. So rec dot boy, that's going to be a little hard. Let's just add it here. Interview ID needs to be an input, so back in interview dot tsx. Also send the interview ID, and here store rec.params.interview ID. Let's create a new function called init sideband. So a new file called sideband.ts, which exports function init sideband, which takes a call ID, string, and interview ID string as an input, and this guy's job is to create like a WebSocket connection to OpenAI, and start to listen to all the messages. So something like this. Beautiful. URL is this thing. Call ID is an input. WebSocket connection with the right headers. .env. Even though there are type errors here. Okay. Where is this type coming from? I hope this works. It might not actually. We'll see. ws.onOpen. When the WebSocket connection opens, we're going to basically forward the system prompt, right? Session.update. You are supposed to interview this user on their computer science intellect. Ask around 2 to 3 questions based on their experience. Now here we'll dump their GitHub, repos and everything, but let's just start here. Let's see if this much works or not. And also every message, let's just log for now. Eventually it should reach the database. Yeah, OpenAI just made this really easy, man. I wasn't expecting it to be this easy. Is there an extra set of brackets somewhere? Maybe not. ws.send and then on open. All right. And ws.on message. What's up with the types here? Where is this coming from? where is this coming from? They use a different library. That makes total sense. One add at types /ws. And now, wait for it. Still waiting for it. Where did I add ws? Did I add it in the front end? I did indeed. So let's go to front end package.json and then get rid of what did we add? ws WebSocket ws, and let's go to the backend, which is right here, and do a bun add ws at types /ws, and now all type errors go away. Hopefully everything from the conversation is now being logged. So now let's try it one more time. Bun index.ts on the backend, bun dev on the front end. Let's go here. Let's create a new interview for Harkirat. And once we reach the second screen, hi.
Hey there. Great to connect with you. How's it going?
Good, how are you?
I'm doing fantastic. Thanks for asking. So, what's on your mind today?
Are you not supposed to interview me?
Oh, we're flipping the script, huh?
Alright, that doesn't look great. Cannot set headers after they're sent to the client. Is an error we got. Init sideband did something weird. Did it? I don't think this ever initialized. Oh, idiot. I never called init sideband. So index.ts, I mean, it did call it, but I never imported this. So let me do that. Cool. Call ID gives an error. Assume it does exist. I did log it, and there you go. We did see it. Beautiful. That's just my bad. Forgot to import the file. Let's try it one more time. Bun index.ts, localhost 3000, a new interview for Harkirat. And now, wait for it. Hi.
Hello. I'm here to interview you on your computer science knowledge. Let's start with your experience.
I have 3 years of experience.
了解了。那我先从你的经验
Man,
出发。
I have 3 years of experience.
All right. With 3 years of experience, let's dig a bit deeper. First question. Have you worked more on front end, back end?
Full
or
stack.
Great. Since you have 3 years of experience as a full stack developer, let me ask a couple of questions. First, can you describe...
Okay, stop. Cool. All right. I did stop it, and now I just want to see. Yeah, the logs are flooded, which is fine. The question really is, how do we get all the messages, which is what we were interested in, which is, what will we eventually evaluating the user on. I should have actually inspected this during the interview. Response.done is like a good, response.done seems like a good message. Total tokens, input tokens, output tokens, input token details, output token details on usage is something we're not interested in. Audio is something we're not interested in. Output is probably something we're interested in. Alright, what else do we have? There's a bunch of deltas which we're not interested in at all. Started is something. Response.done is probably the only thing we're interested in. So what I'm going to do is, in the sideband connection, only worry about messages that have a specific type. Const message equal to this thing, or and then if parsed message dot, let's see, type is response dot done, then I would just log it for now. Parsed message. Alright, now let's try it one more time. Restart the backend. Try giving an interview again. Hello.
Hello. I'm here to ask... مرحبا.
Ask in English, please.
ممتاز. خليني أسألك...
Please ask in English.
تمام. رح حول للإنجليزي.
Bro, something's up with the model or my prompt. One of the things like super messed up. Please use English only during the interview. Alright, let's restart it. Let's create a new interview. Same user. Start interview. Hi.
Hello. Let's get started with the interview. Can you tell me a bit about your background in computer science?
Sure. I have 3 years of experience. I also did a bachelor's in CS.
Great. Thanks for sharing that. Let me ask you a couple of questions based on your experience. First question. Can you describe a challenging project you worked on? And
Alright. So the thing is, I am getting all the assistant messages, which is great. I am not getting all of my messages. So I've probably missed a certain message. Is the response not done?
All right, guys, we've hit a little bit of a roadblock. Let's get into what the roadblock is and what I think is one, generic fix that I can think of. Right now, this is what our architecture looks like. We have the front end where the user is saying a lot of things, and those audio packets reach the OpenAI backend. The OpenAI backend runs it through the model, outputs something, and that output through this sideband reaches us. The goal of the sideband is the backend to let OpenAI know what should be done during this specific voice call, which is doing an interview. The sideband's other goal is for the messages, ideally both this and this, to reach the backend. Unfortunately, that is not happening. OpenAI right now does not support the user messages, the user transcription, reaching this backend through the sideband. And hence, we have to find a way around this. Otherwise, we'll only have the assistant messages. We will never have a log of the user messages over here. There are multiple ways of fixing it. One is, proxy the user's audio through a server and do speech to text on the server. Possible, expensive, can become problematic. We're owning a lot of the audio infrastructure in that case. And, if that's just complicated. If your server goes down, the audio sort of crashes. In this case, all that onus is on OpenAI to ensure the audio architecture. There's no real, WebRTC connections through our backend, which is generally, if you can avoid it, avoid it. If you can offload your WebRTC infrastructure to a provider, do it. In this case, we are doing that. But the problem is we only get assistant messages that can reach the database. This guy never reaches the database because we never receive it using OpenAI. The solution is something like this. Let me just remove this for now. This will come later. But everything else, if you look at, what we will have to do now is continue the rest of the architecture. That includes the front end talking to OpenAI through WebRTC, this guy doing, finally calculating the output of the next question and sending us the question in a textual format. So basically something like this. Sending back the user audio using WebRTC, which runs over here. The user is able to hear the next question. The next thing that needs to happen is the user's audio from the mic needs to be converted to text somehow and reach the backend as well. The user, as they are saying things, whatever they say on this browser itself or on an external server, that speech needs to be converted to text. Thankfully, speech to text is not very expensive, not very hard. You can do it inside the browser. You can do it inside an external service. It will be very cheap either way. Text to speech is expensive. Speech to text is very cheap. So we can actually, use a service like 𝗟𝗶. There are many right now. If you want, we can self-host our model as well. Because text to speech, very cheap. So the text to speech, very cheap. So the user's audio needs to be converted into text here and, through an HTTP layer needs to reach the backend. That way, all of these messages don't come from the browser. They directly come from here. So the user never sends us the assistant messages. User can never spoof that they received easy questions. The user can, however, since this connection is from the front end to the back end, the user can cheat a bit, right? If I ask it a question, they might, hit this endpoint with the answer. There are solutions around this. If they are hitting this endpoint with the answer, then, anyways, they knew the answer. That is why they're hitting it. They might have cheated, but they can cheat in an interview, as well. Even if they speak, they can cheat an answer. So it is not a problem if they're sending us a message right after they were asked a question manually rather than speaking it into a mic. It is a challenge if the user, after the interview ends, sends us a bunch of responses by Googling later. If they hit this endpoint after the interview and, keep piling up messages, that is a problem which can easily be fixed with timestamps. Everything that comes from the assistant, add a timestamp through it. Okay, this came at this time. Everything that comes from the user, also add a timestamp to it. If you ever feel that an answer is much later then when the question was asked, you know for a fact that the user cheated. They in the end dumped a bunch of messages through this open channel that we have, and you can let that know to the final LLM, whose job is to actually find the results for the user. Eventually, we need to do an LLM call that goes through the full transcript and finds the solution, or finds how well the user performed. That can thankfully now be still done. There is some possibility of cheating, but we can get rid of that cheating by adding to the system prompt here. Okay, there are timestamps with every message, and if you feel like the user has later answered a bunch of questions that were asked at a specific timestamp, but they took more than 15 minutes to answer it, that means they have cheated for sure. Given that we understand this, let's get into the next part. The next part is going to cover how do we build this speech to text pipeline. We're going to use 𝗟𝗀, but again, there are many ways to do it. Feel free to use either. And once we've done that, we'll start dumping these to the backend. So we'll expose another endpoint on the backend, and then finally we'll create a transcription endpoint where the user can finally see the results. Without any further ado, let's get into that. All right, let's get into the speech to text bit. I have used 𝗟𝗀 in the past. As you can see, I had like $200 worth of credit. I've spent like $60, but I've never really written this by hand. I vibe coded whenever I integrated this in a place. Today, for the first time, we're going to do this from scratch. So what we want is speech to text. Let's look at the docs. This is fine, but I need docs for Node.js, which I'll probably find here. Let's see. Node, I see nothing. JS SDK, exactly what we need. Hopefully they have some docs. Okay, bun add at 𝗟𝗀/SDK. First thing we need to do probably on our front end. So let me do a cd front end bun add the SDK, create a new 𝗟𝗀 client, dot connect with the model and a bunch of things. Run message delta result connection dot on open this thing. Thing is, we already have an audio track, and we want to sort of we want this guy to listen on it. So let's see, where is speech to text? Real-time speech recognition. Might be it, but I'm sure there's something else I can find. Oh, audio data. What is audio data? Okay, we found something. Let's go to our let's go to random. Let's go to the main interview page, and let's for some time comment all of this logic so that we're not hitting OpenAI every time I'm testing. Given that what we want is, we actually want some of this. We want there we go. Up until this point, we need everything. And let me just uncomment this as well. We don't want any of this yet. We don't want to hit OpenAI. And given we have this MS, which is, the audio track, I don't know why I call it MS. What we want is, here we want 𝗟𝗀 added. So I'm going to now import 𝗟𝗀, create a new client. I probably need, some sort of a secret, probably an ephemeral token again on the front end, which I know that you can create using this. I think all of this logic is fine. The only difference now is, okay, bunch of problems here. Authorization is missing. Okie dokie. What do you need here? A string, probably an API token, I would hope. So let's create an API key, which, again, you don't create this API key and put it on the front end. I'm doing it for now. But ideally this should be on the back end. We should create ephemeral tokens for all of these, but it's fine for now. And now comes the main part. How do I send audio? Hold on. Send audio data. So this thing right here. Now comes the question of how do you send audio data and what exactly does this expect? And the answer is A string, an array buffer, a blob, or an array buffer view. We have audio here. We somehow need to convert this audio track into, you know, bytes. What's the best way to do it? Their API reference doesn't have anything. Let's look at examples. Speech to text is what we need. Oof. This text to speech is text to speech streaming. Transcription live WebSocket 2. That might be it. It's fine. How do you send it data is the question there. That doesn't work. That's a create read stream. What we have is a mic. That should probably do it. We are logging this here. So let's see if it does it or not. What I've done is on top of the user's stream that we're anyway sending to OpenAI, I created a media recorder, which is usually used to, dump this audio eventually locally to the user's machine. But in our case, we're going to wait for bytes on this specific media stream or this media recorder. Every time we get bytes, we're just going to forward it via the connection. And I don't see any type errors here. So I think we should be fine. Let's make it do its thing. So let's do a bun dev on the front end, even though it says it's already running. Let's restart bun dev on the back end or bunindex.ts and then go to localhost :3000, GitHub, give it a GitHub URL, and hopefully we connect to 𝗟𝗶H and everything that I'm going to talk about now gets logged. Never mind. Does not work, probably because this SDK wasn't meant for the front end. Well, the good thing is, the good thing is this is possible directly via WebSockets, or we can add a polyfill, one of the two. What exactly were you looking for when you did not find processor? Let's see. Go to the console, go over here. Somewhere here, you were looking for process.env. Get auth request. Who was calling you? This will be hard to debug. Connect browser to 𝗟𝗏. Create a new WebSocket connection. Let's do that. So let's get rid of this guy and let's add this guy. We have an API key already, which is somewhere here. Let me paste it here. Again, this is a prod API key, should not use it. And how do I send the message though? Is that it? Okie dokie. Don't need this, don't need this, don't need this, don't need this. Again, only on socket.onOpen or something like that, this should happen, right? What we can do is socket.onConnect on open. There we go. Is when we create the media recorder and do everything else with it. So something like this. And there we go. Hopefully this does the same thing. And now whatever I receive on the WebSocket stream, which, this should do it. We receive a message that we parse, and then there's a lot of things here. We'll see what the right thing is. But hopefully this transcript that gets printed is going to be, me talking. Let's see if that works or not. Refresh. Hello, 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 hello. No errors, which is good. Are we logging something? Seems like we are. Ha ha ha. Beautiful. This is exactly what I needed. As I keep on getting responses from 𝗟𝗏, I am going to dump them to the backend, probably 10 seconds at a time or something like that. Beautiful. That's one. Now comes the bigger question. Can this media stream be shared with OpenAI? I am unsure. Refresh. Hello. Hi.
Hello, I'm here to conduct an interview on your computer science knowledge.
Okay. I think I am very interested in that.
Great, let's get started. Could you tell me a bit about your
I think that does it, guys. Man, was this not trivial? But now we're able to log our transcript on the front end, and we just have to expose another backend endpoint where we can send it. So what's really left is wrapping up the backend endpoints, putting both the user messages and the messages of the LLM in the database, and then the final transcript. Let's do that next. Let's wire up everything next. And once we've done that, we're going to get into the more complicated part, which is going to be not the complicated part. You get the idea. This is the last part, which is going to be generating the final result and transcription for the user. Then some UI jazz. Funniest thing happened, guys. You wouldn't believe it. This other mic of mine that I have, it turns green or red when it's not working. It was green the whole time. It suddenly stopped working. So I wrote a bunch of code. I'll take you through it. But once I wrote it, I felt like my mic was working because it was green. I went to the screen and have been constantly trying to debug what went wrong, probably for 20 minutes. Because I feel like my mic's working, and suddenly both 𝗟𝗶 and OpenAI are not responding and not working because they're not receiving any audio because my mic was off. But the last 20 minutes of video, I basically wrote some code, which let me show you. I basically, wrote what you would have expected. I thought this is what broke it, which is me sending the GitHub metadata. Probably did not. So let me reintroduce that. Now in this function, in its sideband, I also added the GitHub metadata so that the user can actually, the LLM actually has context about the user, which also means in my create interview endpoint, sorry, the second endpoint that the user hits with their SDP, not here, directly over here, my bad. I'm just passing the interview ID and right over here, checking in the database if the interview ID exists and getting the user's GitHub metadata from here, putting it over here. That's number one. Number two, as we receive messages from OpenAI, I'm basically, parsing a very complex object that they send, which looks something like this. Excuse me. This is the object we receive. So, this content is an array and this output is an array. So we just flatten the whole thing and, merge them together, and that is what we store in the database. This YouTube video is nothing I was seeing. It's actually, I was me trying to check if my speakers are down or something. So we get the message, we dump that message in the database. I haven't tested this yet, so we'll test it together. And that is the assistant message reaching the database. So this, logic that is added. Earlier I was just logging it. Now I'm actually putting it in the database. The second thing I've added is a new endpoint, which is this /API/v1/session/interview ID endpoint that a user can hit from their browser, and that message will get saved in the database. One more thing I have done is 𝗟𝗶H𝗀𝘀. I added a new created at field and I remigrated my database because now I actually want to in the database store when a message was received, because that will be needed in the final transcript. The thing that is left now, I have a mic in my hand and hence I'll type with just one hand, is somewhere here. There we go. I need to, I can again send it directly once, or I can do it, every 50 seconds or every minute. That probably makes more sense. But, for now, I'll just send it like this. Axios.post, probably the backend endpoint is a variable that we have. Let's see. There we go. / what was the URL that we just created for the user to send their messages to the browser. It was this thing right here. So let me copy that. Let me go back here. Let me paste that. And what we need to send is the actual message, which is going to be this transcript. And the interview ID, which is going to be probably somewhere here, interview ID. There we go. So just copy that and paste that. That should hopefully tell the backend, the user is sending the messages, which is the transcript that we're receiving from 𝗟𝗶H. Hopefully that works in the first go. It may or may not. So let's try an interview. And again, I've been struggling with this screen for 30 minutes. So I hope this time that doesn't happen. Let me copy my GitHub link. Let me paste it over here. Let me click on start interview. And it breaks because the backend is down. So let me restart the backend. And let's try that one more time. Paste it, run it, and now, hello, anyone there?
Hello. Yes, I'm here. Are you ready for the interview? I'll ask you a couple of questions based on your experience in computer science. Let's get started.
Sounds good. Do you already know about me though? Or should I give more context?
I have some idea about your projects from your GitHub profile, but it would be great to hear more directly from you about your
I
experience.
think we can just get into the interview. Can you just ask me a question?
Absolutely. Let's dive in. First question. I see you've worked on a project involving an AI trading agent. Can you tell me about one of the biggest technical challenges you faced
It
while
is
building?
just creating the order finally and latency, managing the latency with the server, the trading server.
That sounds quite challenging indeed. My next
Okay, we can
question.
end the interview now.
Understood. Thank you for your time. If you ever want to continue or have more discussions, feel free to reach out.
Let's migrate the database. Sorry, not migrate the database. Let's check the database out, which should be 1x Prisma Studio. And let's see if transcripts were created or messages were created. There we go. Seems like I messed a few things up. What got stored was object from the assistants, and nothing was stored on the user. Great. I've messed things up. Let's go back here. This will involve a bunch of logging. Let's figure this one out first. Oh, dot join. I did that right. There should be a string. It is a string. I'm missing something. Dot filter. Yeah, I probably have to do a dot map. No, dot map. X would be x dot transcript dot joins. That should fix the first part. Why is the second part not working? API one session interview ID, that should be fine, and API v1 session interview ID, that should be fine. As we receive messages, I think I missed something. Yeah, I'm an idiot. These two endpoints are the same. / user response or something like that, user / response. There we go. Cool. What's the problem here? Cool. So let me just copy this. Hopefully you guys get the problem. I had the same subroute in both the places, which is incorrect. Session / user / response. It says the response now. And let's remove a / here, save it, go back. Says response here, save it. Beautiful. I think. Oh, okay. I don't know what I did there. I'm typing with one hand, so do apologize. Let's see, guys. Let's restart this, and hopefully I'm a little more confident this time. One index, another interview. Man, that's getting like anxiety-inducing now. I have too many interviews lined up. GitHub. Oh, you guys want to see that? GitHub.com / 𝗟𝗶H. Copy it and paste it here. Okay, one more time. Hello.
Hello. Let's dive into the interview. Could you start by telling me a bit about your experience in computer science?
You already have access to my GitHub, right? Just get it from there.
Yes, I do. I can see you have experience with projects related to gaming, augmented reality, competitive coding, and even AI trading agents. Let me ask you the first question. Can you explain a challenging problem you faced while building your AI trading agent and how you resolved it?
It's funny it asked the same question again. Can you end the interview now?
I understand. You'd like to wrap up the interview. Let me ask one quick final question. Based on your experience with AI-driven projects, can you share a challenge you faced
No.
while
Bye-bye. All right, let's see.
Prisma Studio. Go back here. Messages, and there we go. I see a no. For now, do you have GitHub get from there? Yes, I do. Experience. Hello, there we go. I have all the assistant messages. I have all the user messages. I think we're good to go, guys. Yeah, there are a few objects, but I think they're the older ones. They're created at here. Yeah, let's just sort it. Yeah, there we go. Hello. Do you access my GitHub? Yes, I do. Funny as the same question. No answer. Wrap up. You can update it. The order looks fine as well. I mean, so we're pretty much sorted. They're in the right order. It asks. I did something. It asked a question. I answered. It asked a question. I answered. So on and so forth. If you sort it by time, the order looks perfect. One last thing that is left, which is we need to create like a result screen. Of course, we need to fix the UI, but other than that, the user should see a score out of 10 eventually when they click on exit. So we need another LLM call that we need to hit the backend and give the user a score out of 10. Let's do that next. Alrighty, folks, let's wrap it up. We need another front end screen, the results page. So let me quickly create. Is there a folder called pages? Maybe not. So let's just create one here. Result.tsx. There already is one. Beautiful. This guy's job is to hit the backend on an endpoint that we're going to define very soon, and probably poll it constantly because it might happen that the result is not yet ready. So let's do something like this: const result comma set result equal to use state. This can probably be a more complex object. Doesn't have to be like a score. It can be two things: score, which is let's make it 0 initially, and then feedback, that is going to be a string, and then maybe the transcript, which is going to be like an array of strings, or maybe array of type, which is going to be either assistant or user, and then content, which is string. So you can see the transcript of all the messages or the conversation that you did. Result would look something like this. So that's going to be transcript, and then score number, and then feedback, which is going to be a string. We can make this more complex, right? You can have like score based on their behavior, their communication, their I don't know. Communication will be hard because we're doing speech to text, but a bunch of other things. Yeah, their technical abilities, their social abilities, so on and so forth. Let me make this use state of result. Transcript. This is going to be an array, and we simply need to hit the backend now. Get slash backend endpoint or backend URL slash API slash v1 slash result slash interview ID. And this we're going to get from the params. So use params. Yeah, there we go. Beautiful. That should do it. Const response, or dot then response set result response dot data, and then maybe, just maybe, we should also do this on an interval. So set interval, do the same thing every 5 seconds, maybe. Return, just clear the interval whenever the effect goes away. So let interval ID equal this thing, and then clear interval ID. That should do it. Let's implement the backend endpoint over here. So that's going to be, do we have a result here? We don't. We should probably have a result, interview status we have. Interview we have, so probably somewhere here. So there is a score. We need to add feedback here, and then we're good to go. Feedback, optional string, migrate the DB, added feedback, and now this endpoint should be easy enough. app.get /interview ID, and here what we want is await prisma dot interview dot find first, where ID is rec.params dot interview ID, and include the transcript. So include every interview should have a bunch of messages, right? Yeah, conversations. Alrighty. Now we need to map this correctly. So, basically something like rest.json. What does the result enum look like? It has a transcript. Script would be interview.mess conversation.map. C. It'll be type c dot type and then content, I think. C dot message. There we go. That should be one. Maybe created at, but yeah, maybe created at. Every message had a created at, right? If I'm not wrong. It did. I didn't regenerate the client, so let me for next prisma generate, and now hopefully dot create. There we go. Let's add that here as well. Created at, which will be a date, hopefully. Sorry, not here. Here. Beautiful, and then message should just be logged here after they're sorted. So what we can do is result dot score and then feedback, result dot feedback, and then transcript can simply be result dot sort a comma b a dot result dot transcript dot sort a comma b a dot created as plus and b dot created at, or minus. I don't know if you can do it. Probably can. Dot get time. Bunch of squigglies. Okay. Dot map. X dot content, that should be fine. But ideally something like this. X dot type followed by X dot content. That should do it. And in case the backend doesn't have a score yet, that's just the transcript. Score would be interview dot score, and then what is the last thing? Conversation score status should change. Actually, should it? Doesn't matter for now. Feedback, which would be interview dot feedback. If not interview status for message interview not found. But if the interview is found, is when you return all of this. But you need to start a process if the status of the interview is already pending. If interview dot status is pending, in that case, what is the in progress? What is the default value? Status, interview status. There is no default value. Okay. In progress. Should we then end it? I don't know. There should be another status here. Post processing or something like that. but I think this is fine for now. If it is in progress, then we need to basically hit the LLM here. So Axios dot, again, I already have a Gemini API key, so let me put it here really quickly. Gemini API key equal to, let's see, let me quickly get mine. I can just ask Gemini to summarize, give the user points, feedback, so on and so forth. Close, come on, close, there we go. Does that work? Dismiss. It does work, so let me copy the API key, let me paste it here, and then I basically want to send this request with ideally there's a lot of things here, but should be fine. Let me just create another function. So another file called result.ts, export const calculate result. It'll take basically a bunch of messages as an input, which is going to be an array of type assistant or user, and then message string. I think that should be fine, and then maybe created at the string, and then what we want is to hit Google's or Gemini LLM, this thing right here, and then do an Axios request, and whatever response you get, log it. But bigger thing is we need to basically have JSON mode here, which will be tough. JSON mode in Gemini, structured outputs on. Actually, we do need generate content only. We don't really need the, we don't need to stream. Oh, this guy doesn't stream anyways. Generate content. How do you do that? Oh, there we go. Perfect. That should be easy enough. Bun add Zod, and then import Z from Zod. Create the object, which in our case is going to be, output schema would involve feedback for the user. Feedback for the user, and then a score for the user, which is an integer. Score out of 10 for their interview. That should be fine. Okay, we'll have to change this. We'll have to use this API key. Oh, bun add at, what is it? Google/GenAI, and import that. API key, oh, oopsie daisy, would be basically the same thing I had here. There we go. And now, rather than doing all of this, let's make it simple. Let's just use their SDK. Content would be the result prompt. Let me just write result underscore prompt here. Let me move this ahead a bit, and const equal to hi, you are an expert, or not hi, you are an expert evaluator. Your job is to evaluate the user's interview. Give them a score out of 10, and also let them know any feedback you have about their interview. Something like this, and response format, this thing, and what is Zod to JSON schema? That is something. Let me quickly add that as a dependency. Bun add this thing, and now hopefully this would be output schema. What's the problem here? Recipe schema. What's the problem here? Am I missing something? Do you need the type or something? No, this should be fine. I don't know. It says it is wrong, but let's see. Const result equal to response. Output schema dot parse this thing, and if everything is good, we get the result. So something like this. That should be fine. Again, something is wrong here for some reason, but oh, okay, that's not great. Config response format. Nope. Config. Is there response format here? There isn't. This is a string. Does this return a string? I don't know. Let me make this a little more descriptive. Please return only a JSON which looks like this. Feedback string and then score string. Do not return any other text. I think this should be fine. And now I should also pass the user's transcript here. User transcript dot replace user transcript with messages converted to a string. Beautiful. That should probably send the right thing to the user. I think this might not work. They might have upgraded their SDK. Their SDK is incorrect. I have no idea. Google doesn't have the best developer experience. Assuming this does return you something, this should be fine. This guy does its thing, calculates the result, and now index.ts needs to call this, and let's just await this right here. And now let's do a interview dot conversations. And why is this incorrect? Date or string. Okie dokie, let's make a date. Cool. What's the other thing? That's the only thing. Alrighty. Const result equal to this thing. Now I should do a interview dot save prisma dot interview dot update, where id is this into rec dot params dot interview id, and then set status to be done. Data, there we go. Status should be done now. Feedback should be result dot feedback. Wait, there you go. And score should be result dot score. And once, I mean, again, we can just poll this also, which is also fine, in which case, we should just return, which I think is fine. So let's do this. Let's just return and lazily get the results. So the first time you don't really see the result, but you'll keep polling, you'll get the result eventually. Which also means I can also do this, not equal to done. Yeah, that makes sense. Go back to result.tsx, and over here, let's add another field called status, which could be done or in progress or done, in progress or pre, that means pre-interview. Status, which is pre, let's say. And here we can be like, if status is equal to result.status equal to done, only then render these things, else just render like a loader. Cool.
Cool. Moment of truth. I think we've done everything. We've added a new page called result.tsx whose job is to update this variable and keep hitting the server every few seconds. And maybe, just maybe, we should also do this. If you ever get, if it is response.data status equal to none, then also you can clear the interval IT. Then you don't have to pull again. If not response.data oh, oopsie daisy. There's a lot of things happening here. We don't have to send it again the second time, but it's fine. We'll just roll with it for now. We have a page that should hopefully render the user's results. We have a backend endpoint that is doing a bunch of things. It gets the interview from the backend. If it doesn't find one, from the database. It doesn't find one, it lets the user know. If it does find one, it gives the user the current value. And if the interview status is not done, starts to calculate the result. We should put some sort of a lock here. If only one, this should only happen once at a time. Right now, if I send this request like 20 times, it'll just hit the LLM 20 times, which is not great. So like a good edge case to do. Should add some sort of a lock here, and other than that I think we should be good to go, but never say that before testing, which means it's time to test, guys. My biggest worry right now is that this calculate result function, the result that we get back, the text that we get back is not correct, as in it's not formatted correctly. So let's hope that happens. I'll also log it. With that, I'm going to start the backend. I'm going to start whoopsie daisy, the front end, which already is started, and let me start a new interview for Harkirat Singh, who is seems like he has some GitHub in there. Interview started. Hi.
Hello. Let's get started with your computer science interview. Based on your GitHub, I can see you have experience with projects involving AI, web development, and even blockchain technologies. Could you tell me a bit more about your experience with AI trading agents? Sure. Let me ask about that. How did you approach integrating large language models into your trading agent project? And what challenges did you face?
I tried integrating multiple LLMs. I used OpenRouter. The goal was simple. Given a bunch of financial indicators, and our current positions, what positions would the LLM take right now? That included starting a new short or a long, closing an existing position, and then I just let the loop run like every 10 minutes.
That sounds really interesting. So the LLM was making decisions on opening and closing positions based on real-time indicators. Now, could you explain how you evaluated the performance of the AI trading agent? What metrics or benchmarks did you use?
We had a public benchmarks page that was just showing how well various LLMs performed. Long story short, everyone lost in the long term because of the spread. So I think it was like a fairly average strategy that any other trader would use, and ended up, just blowing in our faces in the long run, because the trading fee and the spread sort of ate up all of any profits, if at all.
Thank you for sharing that insight. It sounds like dealing with spreads and trading fees was a major hurdle. Now, let me ask you a final question. If you were to redesign this AI trading agent, what improvements or changes would you make to enhance its performance and profitability?
I think profitability is still up in the air. I think the output is as good as the input, specifically for a use case like this. So, one, I don't think LLMs were ever trained to do this. So, they're just making guesses based on, what they see. Two, we're always talking to them every 5 minutes, which is not great. I think, this sort of makes sense at a shorter frequency. The problem though is, LLMs are really slow, so you can't really use them for high frequency trading. I would probably, go back to basics and understand if AI ever does solve this, how would it be? How would you train the model? The inputs and outputs would probably look very different. I think LLMs were never trained on HFT data. They're always trained on text, from the internet, which has a lot of knowledge around this, but I'm unsure if it actually has, all the pieces that a trader uses in their brain to figure out strategies.
That's a great reflection. It seems you're No problem. I completely understand. It's a complex challenge, but your observations are really
Let's end the interview now.
understood. Thank you for sharing your insights and experience. It was great hearing about your work. Good luck with your future projects.
All right, where is the result page hosted? Now that that interview is done, app.tsx. That is it, right? Slash result share this thing. Seems like it. Slash result slash interview ID. Slash result slash interview ID. Should render this. Result. It's the right page. Is it hitting the backend at all? Oh, it is. Response. Oh, get the transcript. No feedback yet. No score yet. All right. So status is not done. Man, am I firing up a bunch of LM requests that I shouldn't. Look at the backend. Are you not returning me right things? Oh, there we go. Number एक string आ रहा है. चलो, that should be simple. Feedback and score. Beautiful. Okay. Solvable problem. Number. My bad. Should be number. Shouldn't be score. Let's try that one more time. If I open the result page now, it will poll and should show some sort of loader, but eventually, hopefully, the next time it does work. Yeah, perfect. Should work now. Come on. I think it should work now. Oh, score 8. There we go. Feedback something, and then what is the status? Oh, status is never returned. My bad. Solvable problem. Cool. Restart, and now if I refresh, it will show me I have an 8 on 10. Oh, okie dokie. Get time. How do you sort, dude? Let's just assume it sorts correctly. It probably doesn't, but I will make that assumption. Fresh. Okay. Yikes. A lot of things. So br slash. All right. Score 8 feedback. You demonstrated excellent critical thinking and technical honesty, admitting that your trading unfairly lost due to real friction like transaction spreads. Additionally, your answer limitation is a high latency, making it to high frequency, and the fact that thing was a highly accurate and insightful to improve work on your communication structure. And so highly fragmented across short messages with some voice to text typos. Practice, yeah, I mean that's just text to speech. Cool. And then the transcript, which let's see. Hello, let's start the interview. Sure, how do you approach this thing? Okay, I don't know what happened here, but there was like something is up with the voice model. I tried integrating multiple AI की जगह I है. Use open router. The goal is simple. Given a bunch of financing indicators what are the current positions, what would to assist empty messages, include in starting new shot, or along the lines of, okay, this is like a lot of empty assistant messages that we can easily get rid of, and we probably need again turn detection on speech to text. Like when the user stops talking is when one message should go, rather than the transcript being all over the place. Still, I think thankfully text models sort of understand this. But this feedback, everyone will see, messages being fragmented, which should be easy to solve, using turn detection on the deepgram side. Cool. So we have an interview page, we have a results page, we have a landing page. What do you do next, guys? You vibe code the front end as always. So, I'm going to now go to my trusted friend, Devin, and ask it to do a few things. I've completed this website, please finish the front end design. Everything else is in place. I've not spent any time on the front end. I should probably change the model. This is like a slightly, I would call it, design heavy task. High is good. For the landing page, users should just see a input box and a button to start their interview. Everything, keep it a single page app. No scroll should be needed on this page. Number two, for the interview page, it would be nice if we can capture the two audios and show indicators. So when the AI is speaking, we show some sort of animation based on its volume slash strength. Same is true for user when the user is speaking. The results page should simply be a clean page with the feedback from the AI and the message history. That should be good enough. Let's see what we get if we wipe code a front end for this one, which I always do, guys. You don't write front ends yourself. I mean, you should, but I don't. Let's see what happens when this finishes. Alright, guys, it just finished. It's done a few things. So landing page, made it prettier. Interview page. Did it add? It did add a voice orb.tsx component that hopefully is like an orb that moves along with the voice. A results page and a bunch of things. Apex Harkirat, beautiful. It caught that and it added an end interview button, which is great because we did not have one. It did ask me in the process amongst the questions, should I add end interview button? I said yes, and hence it made it. Let's restart the backend. So that's going to be apps/backend bun.dev or bunindex.ts. Let's start the front end. It's already up, but since there's a lot of changes that have been made, I will restart it once. And man, could it look more vibe coded? Couldn't, but at least, I mean, better than what we had before. So I am not complaining. Start interview. Starting. Beautiful. Allow this time. Hello.
Hello. I'm here to conduct a short interview about your computer science knowledge.
Let's do it.
Great. Let's begin the interview. Based on your GitHub, I see you've worked on projects involving competitive coding resources, AI-powered trading, and even augmented reality for the web. First question. Can you tell me about a particularly challenging problem you solved while building the AI trading agent?
Every time it asks the same question. Well,
Take your time. Think about a specific challenge you faced. Maybe it was related to the model's accuracy, handling real-time data, or integrating with other systems. I'd love to hear the details.
mostly it's a simple project, right? You write, I mean, these are LLMs, text-based LLMs. There's not much trading information you can feed into them. The only new thing for me, the challenging part was I've never done finance. So figuring out all the indicators that you use, that traders probably use, and forwarding them to the LLM. But while I was doing that, I realized, there's a lot of number crunching that LLMs are not necessarily good at. And hence, the final output wasn't great.
That makes a lot of sense. So, my second question is, how did you approach improving the performance of your AI trading agent, given those challenges with number crunching and financial indicators?
Well, I mean, you can it's like throwing money at a problem that can't be solved via money. You can add more indicators in there, you can do a bunch of things, but I doubt that's how someone who's currently working in an HFT thinks about these. An LLM can't do high frequency trading. It's really slow for it. So it's effectively doing slightly long-term strategies. It's probably being given data every 10 minutes and it's making certain calls on top of it. That's probably, the best you can do is throw as many things that you can at it and, just hope it spouts something great. But yeah, that's a high level. Can you ask me about other projects now?
Absolutely. Let's shift focus. Here's the next question. You've got a project called the 2D Metaverse with quite a few stars. What was one of the key technical hurdles you encountered while building that project, and how did you overcome it?
I mean, it has a lot of moving pieces, right? There is WebRTC because everyone needs to talk to each other. It's like a metaverse space where people can talk to each other. There's spatial audio. If someone comes close to you, is when you can hear it. There's a very complicated problem of if you are in a very big space, but you're only surrounded by 5 people. You should only listen to those 5 people, and also the backend should only send you the audio of those 5 people. The challenge that comes there is the video backend, that's the SFU, needs to be aware of your positions, which becomes like not a hard problem, but it can get ugly quick if your video server is aware of people's positions. So the permission logic that ensures that if my CTO is very far from me, there is no way for me to get their audio or their video if they're in a private meeting. Getting their video should be impossible. That's the harder part.
That's a fascinating challenge, blending real-time communication with spatial awareness and permissions. Now, how did you ultimately solve that permission logic problem?
That is signed under an NDA, so I can't share. But you can think of a few ways to do it.
Understood, and I completely respect that. We don't need to dive into specifics. Let's wrap up with a broader question. Across the projects you've worked on, what's one key lesson you've learned about tackling complex technical challenges?
I think the more you bleed while reading the problem statement and brainstorming over it, the more you sweat over there, the less you'll bleed eventually. I think right now with AI coding, it will probably be implemented by the AI. So the more time you can spend as a developer thinking on edge cases, the better output you'll probably get. And hence, I think a recent learning for me has been the more you sweat on thinking, the less you'll bleed after the AI spits out the outcome.
That's a powerful insight. Investing time upfront to really think through the problem and all the edge cases can truly save a lot of trouble down the line. Thanks for sharing your experience.
Thank you. Have a good day.
You're welcome. Have a great day ahead, and good luck with all your projects.
All right, analysis happening. I think that was a pretty decent interview. I don't know about you guys, but I get a score of, wait for it, either the backend is down or man, was it a great interview? Oh, there we go. Cool. I get a 7 out of 10. That's the problem, right? I mean, there is a problem right now. The messages are broken a little too much, but still sort of works. I mean, I think it was a pretty good interview. Why did I get a 7? Think you're final inside for spending more time on upfront conceptual thinking. Well, your communication style system is highly fragmented. Again, the same thing again. Yeah. I don't think this is a great interview platform. I'm telling you that. This was at least a 9 on a 10. I mean, purely because of the questions it asked. I was just, sort of overly prepared on these questions for many reasons. Time to end it. Hopefully, you guys learned something new. I'm not deploying it. It was pretty expensive. So, I'm sure I spent probably 50 cents or a little less on this interview. But boy, is it good. Like the real-time API by OpenAI is there when it comes to, just being a great, just feeling like a natural conversation, even though it's expensive. And hopefully you guys learned something new from the video. Hopefully you guys understood everything by the end. Again, this video was sponsored by Data Impulse, so do check them out. And we use them as our parsing friends for this video. And if you're ever, if you ever need proxies at all, they're your friend. With that, we'll end it. I will see you guys in the next one, and let me know what kind of a platform would you like me to make next. Bye bye, guys.